Ja, goedemiddag dames en heren en welkom bij mijn presentatie Consumer Choice Studies on LED Lamps. Now you've already seen that I have quite an accent when I attempt to speak Dutch, so I shall continue in English if that is okay with you. It's a language that I'm a little bit more familiar, but I've started learning Dutch, and hopefully next time when I'm here I may be able to speak a little bit more Dutch. What I want to talk about, the consumer choice studies on LED lamps, is not related, like other talks, to understanding the technology, understanding how to measure the characteristics, the technical characteristics of something, as you would expect for somebody who's in the field of lighting. But it also it is actually focusing on something on understanding the market. I had a talk or a meeting earlier today where people said, yeah, the engineers very often focus on the technical things, but it is equally important to understand the market. And that's usually a very weak point in engineering as they focus on technology. And that's actually pretty true, what I can see from my own experience in my former company, BC Hydro. And we have been trying to direct some of our research towards understanding the market together with our marketing department, but also with a very strong input from the technical engineers, and in this particular case that I'm presenting today in the field of lighting. So I brought you a picture that is actually a very important building in my former home, British Columbia. That is the legislative building in Victoria, British Columbia, the capital of this province, this very beautiful province. This is where all the regulations regarding energy efficiency are being made for the province, and the province is also leading the way. All these little light points that you see used to be inefficient incandescent lamps. They have been replaced. All 3,000 of them have been replaced with much more efficient technology. Something that has been done as a group project. It was actually a public-private partnership between a university and the industry. So the talk that I'm giving here was presented earlier this year at the 20th International Symposium on Society and Resource Management, and the title of the talk was Integrating Consumer Preference Choice Models into Electricity Forecasting. There was a whole bunch of us working together. So we have colleagues, Paul Osmal, Ken Tiedemann and Mark Peterson from BC Hydro, and Professor Dr. Wolfgang Haider and Sergio Fernandez from Simon Fraser University, and within there they were in the School of Resource and Environmental Management. Wolfgang is the director and professor there. Sergio is a PhD student. On the BC Hydro side, we had 3 different departments involved. It was the BC Hydro Power Smart Evaluation, BC Hydro Rates, and BC Hydro Policies, Codes and Standards. So I want to give credit where credit is due. This was done by a group of people in a public-private partnership. As an overview, I want to give you the motivation. Why did we do this research? What was the scope and the aims? What methodology did we choose in order to understand the market? Obviously, I also want to share some results with you and come to conclusions. As a motivation, we first need to see in what scope we have been working. BC Hydro is a company that provides electricity to the province of British Columbia, so the southwesternmost province of Canada, in the Pacific Northwest area. The market is roughly 1.7 million residential accounts, some commercial accounts and large industrial accounts. The usage within the accounts is pretty much 1/3, 1/3, 1/3, and we have been focusing on the consumers, so on the residential market, so 1.7 million customers or accounts. We wanted to understand the market in terms of the choice of lamps. the normal screw-in lamps, the general service lamps. In light of the regulation, the incandescent lamps will not meet the regulation that was effective January 2011 in the first phase and December 31st, 2014 in its second phase, so it's around the corner to come. But we had really good data of the stock. We knew how many lamps were there. Every 2 years we did a residential end-use study, so we understood the current situation in the market. We understood how many lamps there were. And we understood that there were X% of this lamp type and X% of that lamp type. But how about the consumer decisions when you replace the lamp? Will they replace like for like? Will they replace something with something more energy efficient, something that we were actively supporting through incentive programs and through promotion and through outreach and all these marketing tools that you have available? Or will they choose something completely different? Well, in the next time step, what would then the market look like? And so on until your planning horizon. The planning horizon, depending on what projects you're in, could be 5 years for the short term, but we were also required to provide forecasting that exceeded 20 years. So if you're thinking like for like, you don't have to do anything. The assumption may be wrong, but you take the numbers that you have today and that will be the picture for tomorrow. But as you want to push energy efficiency, you obviously want this to change, and you need to know what drives the people to choose something more energy efficient and what parameter exactly will drive it a little bit more. So we gave them a choice study where we basically presented the participants a certain choice. So you have different shapes, different colors, different prices, different here, different there. And they chose something, and based on the choice and the statistical analysis, we could say that under these parameters, they may more likely choose this, or they will choose this with a likelihood of X%, and that was the goal. So the statistical modeling came after we collected the raw data from the participants, and then we could attempt to forecast the market shares based on the probability of choice. Now these stated preference studies are not new. They have been very often and very successfully applied to different markets, to different market research. Actually, by this very school that I quoted in Simon Fraser University. They applied it to vehicles, they applied it to travel and tourism and to the environment in general. But this, to my knowledge, was the first time that this was done for the energy efficiency market and for the lighting market. At least, for sure in British Columbia, very likely in Canada and possibly also in the United States. I don't know what the situation is in Europe is. I have been away for a little bit over 9 years. Currently, the model estimates based on the stock data on some forecast, which is relying on expert opinion. An opinion is an opinion, and it's not necessarily something that you can scientifically undermine or prove. An opinion is an opinion. If you ask me about my opinion, what numbers will be chosen next Saturday at the lottery, I can give you my opinion. So far, every weekend, I've been wrong. Well, I'm also not an expert in that particular field, but you immediately see that the opinion may not necessarily give you a very good security in your forecast. You actually have to reduce the uncertainty. I'm a very uncertain lottery number forecaster. So don't ask me, I don't know. Or ask me and choose other ones that you ever so slightly increase your chances of winning. Now, what's the advancement that we offer? We still need to do the step T+1. 1 year after, 2 years after, until we hit the planning horizon of, let's say, 20 years. Well, we do the preference choice outcomes. We have a choice model and we understand the decision drivers afterwards. And then we forecast the available products. A regulation may create an interruption because a certain product type may not be available. Innovation, on the other side, will create or may create at some point a new technology that we don't know about that has to be introduced, and at that point you have to redo the survey, but you understand and you forecast all the drivers, you try to forecast the prices and so on. There's another uncertainty that comes in. So whatever we come up with is still having an uncertainty, but in our attempt we try to reduce the uncertainty and try to forecast the decisions based on replacement and new purchases and based on a little bit of the statistics there. So how does this work in the methodology? We had 64 choice sets, an orthogonal design for those who know what it is, and you could choose between different technologies, the light emitting diode, the compact fluorescent lamp, the halogen, and the incandescent lamp, as the incandescent lamp is still available in these areas in the market. And then you apply a probability for each of these technologies, and you understand what is driving. So every participant got 6 choice sets, and he had to choose what he preferred. So again, in our market, 1.7 million residential people, we sent out 3,500 surveys and got a return of a little bit over 1,000. We assumed that this is representative of the customers, but obviously it's difficult to say that for sure. And you see that this choice experiment is now fitting into the informed consent and all the requirements until we got all the required parameters that may be relevant. So what the people saw, what the people saw is this. You have different lamps with different characteristics, and choose which one you would buy if you were to replace this lamp that just burned out. And you can get a little bit of a deal when you buy a package. There can be a coupon of 15%. By the way, this is your annual bill for running this lamp, and so on and so on. But they had to choose. Now to the results. And before I show you the results, I have to give a little bit of a disclaimer. For all data resulting from scientific experiment or surveys, as in this case, also scientific surveys actually, it is important to understand the value of this data, but also its limitations. The value, I hope I could sort of hint on it already, but the limitations is very, very important. The data represents the choice made by people living in British Columbia. So the results may not be transferable one-to-one to the Dutch society, because the information of the consumers may be different. The knowledge may be different. Even products may be different. So it is a little bit problematic, and I don't want to imply that the findings of this are likely or like for like being transferable to Europe or to the Netherlands. But I think the trends that we see may very well be. So we have a model validated. We saw the typical proportions. If you lower the price, the likelihood goes up, and so on. If you have a lamp with a higher life, it's also going up that people choose this more likely, and so on. And we saw that the operating cost matters, the technology type matters. It's very strong and a positive preference for light emitting diodes, which was very good for our strategic direction of helping with the retrofit towards the more energy efficient lighting in residential homes. The lamp life matters. The brand is statistically significant, so we could not test for specific brands, but we said well-known brands versus no-name brands. And coupons also have an impact, which was also good because we provided these coupons as a company in BC Hydro. So the current situation is roughly a third choose LEDs, CFLs, and incandescents based on the current prices as we see them on the shelf in the DIY stores, the big box stores, as well as the small mom and pop stores. But we can also derive more. And all of this data is also preliminary because it's potentially subject to IRs, information request, due to the fact that the utility is regulated. So this is not finalized, it's not official yet, but it is preliminary, another disclaimer that I have to share with you. So if you have a current price of $7.50, roughly €5 for CFL, and you have a single package of $19 in LED, you can see how the likelihood of choosing the LED, the likelihood of choosing an CFL increases as the price of a CFL drops, while the price of the LED stays the same. In the same manner, horizontally now, if the price for a single CFL stays the same, but you change the price for a single lamp, sorry for the word bulb, lamp for the LEDs, you see that the likelihood of buying an LED also increases. Just the normal thing that you would expect. And then you can combine these two and you have a matrix where you can see what happens if I change both. If one price drops, the other one drops, or the other one increases, and so on and so on. So you get a whole bunch of things, and you can actually tell what the sweet spot may be if you have a certain interest of selling one versus the other technology, for example. Now on my last slide, you see we have these inputs. We have to do the projections for each parameter. We have the modeling based on the probability things, and we then try to predict the market shares. And this is very useful for the energy and demand forecast that we're doing just on the business side. The design of incentive programs, so how much of an incentive should we give that we get the maximum bang for our buck, as we say in Canada. The modeling of the impact of federal and provincial regulations, that means codes and standards, can be supported by this, and the strategic planning of activities in the short, medium, and long term can be informed and shaped by this. I think, and this is why I chose and wanted to share this information with you, that this is actually a very good example of a public-private partnership where industry and university-based research comes together and creates a meaningful result for both of them. And actually that is exactly what we do in the Intelligent Lighting Institute. This is actually also closing the gap, or closing the circle of my talk back to the Intelligent Lighting Institute, because this is part of what we're trying to do. We try to create a scientific community of practice dedicated to intelligent lighting solutions with a scientific and application-based approach. We also try to establish partnerships with stakeholders in the public and private field. We try to apply a multidisciplinary and multifunctional approach, concept-driven, evidence-based. All of these three things that I just said were done in exactly this project. And the Intelligent Lighting Institute adds another thing. We also want to realize human-centric, real-life test beds, the living labs. In this particular case, there was no application for a living lab, but basically the research that has been done here is pretty much what we do in the Intelligent Lighting Institute. Thank you all for your Aandacht, and if you have any questions, more happy to